Hey there, Algebra 1 Eagles. So this video is the second video about your culminating performance assessment. Kind of the overview, its purpose, the grading rubric are all, and how to submit it are all found on the first video. So make sure you check that one out, or like after you finish your project, if you can't remember how to submit it, go back and watch that. You can either email it to your teacher or you can submit it via Schoology. Okay, so let's get down to the nitty-gritty. So here's what we want to do for you so that you understand exactly what each question is expecting of you and how the possible ways to do this with technology are. We've created a mock CPA, mock culminating performance assessment. So we're going to do basically the same project you're going to do, but I'm going to switch up the graphs and I'm going to switch up the numbers and the names a little bit. So if you can follow along with these processes, then there is no reason that you get any kind of bad grade on this or don't do it at all. Okay, we're trying to set you up for success. So we want you to start with these videos, see what you can do, and then reach out to your teacher for further help. Okay, so let's start by looking at some of these sample problems that you might see on your culminating performance assessment. But first, let's kind of flip over and just talk about what we need to make sure that we have on our project so that we can get grades on it. Okay, so let's look at that. Okay, so let's talk about the things that you need to have on the top of your paper. Okay, no matter what, anytime you turn in a homework assignment, any class, forever, okay, you need to make sure that, of course, you put your name. Okay, let's also go ahead and put our teacher and our period. Okay, and then you can write CPA if you want to write performance assessment. Just let us know what this for sure is your project. It can be in the header, it can be on the left, on the right. We're not going to be picky about that, but let the first thing on your paper be your name. Okay, and then from there, we're just going to write number 1, and then you're going to have your answer. Okay, so we're okay with you doing this lots of different ways. Okay, you can put your answer, you can type out your answer and just have it there. If you write it out on a piece of paper or you do it on your phone and you screenshot it, then you can attach a picture onto this document behind number 1. Okay, we are going to be flexible with how you do this because we understand that some of you are having to do all of this from your phone. So if you write it out on your phone and you have a bunch of screenshots, then just ask your parent, or you can email the screenshots and put on there number 1. So we're okay with you guys doing this in different ways, but we need you to talk to us, communicate, and then the best way though is going to be put it all in one document, and you can attach pictures or you can just type. And I'm going to show you exactly how to get to all those equation buttons so that you can make like the less than signs and all that kind of stuff. We're going to do that in this video, okay? So that's the first thing. So let's go look at our mock CPA so that we can see what kind of questions we're going to see. Here's question number 1 on our sample performance assessment. It says determine the domain and range of the quadratic function shown in the graph and represent the domain and range using inequalities. Okay, so domain and range. Hopefully we remember domain are x values, are left to right. So we ask ourselves, how far left, how far right? Okay, and then if we are working with range, it is our y values are up and down. So we're going to ask ourselves, how low can we go? How high can we fly? Okay, so keep those things in mind. Okay, so the first one, we have to remember those endpoints. Because it doesn't have arrows, it doesn't go on forever. Okay, so let's do this. So we're going to go, let's see, how far left? So we're working with our domain first. Let's find our domain. Okay, so I'm going to see how far left does it go. Well, remember it's x value, so I'm looking at the x-axis. Okay, so we're going to see how far left. It goes to -3. So I'm going to write that, -3. And when it has endpoints, we told you guys it was going to be less than signs. And then if it's a closed circle, remember closed circles are going to have the or equal to line. And open circles do not. Okay, so we told you guys the domain and range that it's, if you do it from left to right and low to high, then it's always going to be a less than sign. And then it's a closed circle, so this one's going to be less than or equal to. Domain is our x values. And then we're gonna have another less than sign, but let's see how far how far right do we go? So we go all the way to 2, and it's an open circle. So I'm gonna leave it with just a less than and put 2. That's my domain, that's it, okay? So then I'm gonna see how low do I go? How high do I fly? Okay, so let's see, how low do we go? Well, it doesn't have to be an endpoint. My graph dips all the way down to that minimum point right here at -7. So my range is -7, and when it's part of our graph, that's like a close point right there that touched that -7. So if it touches that, it's like a close point, then it's less than or equal to. Range is our y values. And then we're gonna see how high do we fly. So I fly all the way up to this point up here, and that's on the y value of 2. So, and then it is a closed circle, so we would say less than or equal to 2. And so that's our answer. That's our answer for number 1. So on your document, you could either screenshot, if you were to write it on your phone and attach it, or on our document, we can just do this. We can flip over and we can write, we can go insert, okay? And then at the top, there's gonna be on the top right, there's a button that says equation. And so you can just write, well, actually, let's go domain first. We have to write domain. The D, you can write out domain if you want. And then we're gonna write insert equation, and then you're gonna type -3. You see all these buttons up here after you pushed equation should have opened up all of these equation options. And so I'm gonna push that less than or equal to X because it's domain. And then we figured out that it was a less than sign, and it was 2. So that's my domain, and I'm gonna arrow out of it. And I'm not ready for number 2 yet, so I'm gonna write range. I'm gonna open up, go insert, all the way to the right, equation, and then I'm gonna type in -7, less than or equal to, range is my y values, less than or equal to 2. And that's it. Now we're ready for number 2. Okay, let's look at number 2. So this is for each situation, write a representative quadratic function with rational coefficients, identifying each attribute. So we're going to find the domain and range, we're going to find the x-intercepts, the y-intercept, the zeros, maximum or minimum, the vertex, and the equation of the axis of symmetry. Okay, so we're going to find all those things. So we actually have a video that we created a couple weeks ago that if you need to go review for more over these things, you can access that video. You also have notes on these in your notebook because we covered all of this even before spring break, and we've revisited that's how important this is. Okay, so you're gonna have 3 parts to this one. You're gonna have an A, a B, and a C. Okay, so I'm only gonna work 1 with you, 2-ish. I'm gonna work 1.5, I guess, with you of these problems. Okay, so that you can see kind of your expectation, but you're gonna have one that's an upward facing parabola, and then you're gonna have one that is a downward facing parabola, and that's the one we're about to work together, and then you're gonna have one that's like part C, and we're gonna do part of that one together, okay? So let's kind of just start with our attributes, and then we'll transition, we'll talk about how do we write that representative function. Okay, so let's start with our attributes. So we're looking at domain and range first of all. Okay, so remember domain and range. Domain is how far left, how far right, those x values. Okay, but look, how far left it has an arrow, and how far right it has an arrow. So if something goes forever left, forever right, then that means that its domain is, hopefully you said all real numbers. Okay, and then we have our range. Okay, so remember, range is how low can we go, how high can we fly. Okay, so we're gonna see how low do we go. Well, we go all the way down, forever, never, never, because there's arrows. Okay, so something goes forever down, but it only goes up to 8, has a high point. So it's pointing down, or the y's are getting smaller. So we would say y is, instead of smaller in math, we normally say less than, and then that's a point right there, so or equal to 8. And that's your range. Okay, so then we had to find our x-intercepts, so let's find those. Let's just write x in for the sake of space. Okay, so we're gonna find our x-intercepts. So we have an x-intercept right there, an x-intercept right there. Remember, with parabolas or quadratic functions, we can have 0, 1, wait, we can have 2, 1, or none. I think that's how we said it in class. 2, 1, or none. All right, so then this time we have 2. Remember, all x-intercepts have a y of 0, so we write these as ordered pairs or coordinate points. So -3, 0, and that is 1, 0. Okay, then it said to find our y-intercepts. Oop, there it is, where it runs into the y-axis. And remember, y-intercepts all have an x of 0. So when we write that, we're going to write 0, 6. Okay, the next thing on the list was zeros. Now, hopefully you remember that's a special vocab word. Okay, x-intercepts are the same thing as zeros, roots, and solutions. So you have to know all those 4 words. All just mean we're looking at the x-intercepts, or when we find the solutions to a quadratic equation, it's the same thing as the x-intercepts when we graph it. Okay, so you have to know that those things weave together, they work together. So we found our zeros to be, you can just rewrite them as the x-intercepts. We are okay with you writing it that way. So it could be -3, 0, and 1, 0. You also could have said that they were at x equals -3 and 1. Okay, so then it said after that, we had to find if it was a maximum or a minimum. So this it's pointed down, it's a mountaintop, so that means it's got a maximum. And when we're looking at maximums and minimums, we're looking at that vertex point, and max and min is that y value of that vertex. So what's that highest point in this case? So we would say y equals 8. And then we had to find the vertex. Remember, the vertex is the very point of our parabola where it turns, it starts to go the other way. Okay, so that is our point right there. And so that would be at -1, 8. And then the last thing it wants us to find is our axis of symmetry. Okay, remember, our axis of symmetry is written as an equation of a vertical line. And remember, if you remember when we did Hoy and Bucks, remember HOY is for horizontal lines, but VUX was to teach us about vertical lines, V for vertical. So it is this invisible vertical line that cuts this parabola perfectly in half. And so V for vertical, the U is undefined slope, but what we're looking at is the equation. So that X equals a number equation, and it's gonna be the number that it passes through, or the X value of our vertex. So we would say that our axis of symmetry is at X equals -1. Okay? So before we go to write our function, let's go ahead and kind of dump our brain of these things in our document, okay? So here we are in our document, so I'm gonna write number 2, and then let's go part, or letter A. And then we're gonna find our, actually let's go like this. Part A. It doesn't have to be perfect. If your formatting's weird, we'll figure out what you're doing, but just make sure you identify things, okay? So part A, and then you would have had your domain, you would have had your range, you would have had x-intercepts, y-intercepts, zeros, max or min, which is hint, hint, that was opened up, so it would have been a minimum. I don't remember in your PA which one it is. Don't totally take that for word. Okay, and then we have the vertex and the axis of symmetry. Okay, and then we're gonna go to part B. And I'm gonna go domain. Okay, and so remember how you get to your equation button. Ooh, but this domain is all the numbers, so I'm just gonna write that in. We'll do the equation button for the range. Okay, so we have range is, and we're gonna go insert, and then over on the top right side of your screen, you see the equation button, so it's gonna open it up, and then remember this bar up at the top is gonna give you all those inequality symbols you're looking for. Okay, so we're gonna have y is less than or equal to 8. Okay, and then I'm gonna put in my x-intercepts. You can use the equation tool for points, but you don't have to. We'll know what you're talking about. Okay, so then I had y-intercept. And zeros. I'm gonna rewrite those. And it was a maximum this time, and it was at y equals 8, and then we had a vertex at -1, 8, and an axis of symmetry at x equals -1. Okay, so then now we're going to write our function. We're going to figure out our representative function. So let's flip back to our problem and talk about how we could do this. Okay, so here we are. So let's look at how we could write the representative function. Technically, you have two options. So you have one way where you could use the x-intercepts and the y-intercept. So let's keep those in mind. So we have our x-intercepts and our y-intercept. Or we have another way that we could use our vertex and our y-intercept, or our vertex and another point. Okay, so let's flip over and let's see what happens. Okay, so if we remember, we have the standard form of a quadratic function looks like ax squared plus bx plus c. Okay, so if we're going to set this up, we knew factored form was really easy whenever we would have the two x-intercepts. Okay, so our factored form, that's standard form. Factored form looks like a times x, I think it's plus, oh, I'm sorry, not plus. Minus p x minus q, and then our vertex form is a times x minus h squared plus k. All right, so those are our major forms. So we have to keep all those in mind. Okay, so you have two options for this with the information that you're given. Okay, so we can take our factored form, because we know our x-intercepts. Remember, this gives our factored form gives us x-intercepts, vertex form gives us vertex. Okay, so let's try that factored form. Let's try that one first. Let's see what we can do with that, because we have our x-intercepts. Okay, so I'm gonna write y equals a, because I don't know what my a is yet, but I know what my x-intercepts are. So parenthesis x, and it's minus p, so it's going to be the opposite sign. So we had an x-intercept at -3 and an x-intercept at +1. So I have -3 now becomes +3, and then our other one was a +1, so it becomes -1. Okay? So then now I'm going to use FOIL or double distributive or shirts and pants to be able to simplify those binomials. Okay, so what we're going to do is we're going to hippity hoppity distributive property. Okay, all 4 times. Okay, so I'm going to leave the y equals a alone and open up parentheses. And so it's got x times x is x squared. X times -1 is -1x or negative x. 3 times x is positive 3x. 3 times -1 is -3. And so I'm going to simplify inside the parentheses. Negative x plus 3x is positive 2x. And then we're left with -3. From here, personally, I think this one might be the easiest way, but I'm going to show you both ways for whichever way your brain likes better, okay? So then from here, I need to find that a. So I'm going to bring over that other point that I knew. So remember, I knew my y-intercept was 0, 6. So I'm going to plug in that 0 wherever I see an x, and I'm going to plug in that 6 wherever I see a y, and I'm going to solve for a because I need to find a. You can't leave the a in there. If you leave the a in there, you won't get your points, okay? That's not the answer. Okay, so we need to go solve for that a. So this is what we're looking for. Okay, so we're going to plug in our 0 in the x spots and our y in, or 6 in the y spots. Okay, so I'm going to go 6 equals, leave the a alone. Well, I have 0 squared plus 2 times 0 minus 3. Okay, well, 0 squared is just 0 times 0 is 0, plus 2 times 0 is 0, minus 3. Well, that leaves me with 0 plus 0 minus 3 is just -3. And so now I need to divide to get my a. So 6 divided by -3 is -2 is a. So then I'm going to take this and I'm going to rewrite it, or I'm going to substitute it in to this equation, this part right here, and then I'm going to simplify it. Okay, so I have y equals -2 times x squared plus 2x minus 3. And now I'm going to hippity-hoppity distributive property and simplify that out. So I have y equals -2 times x squared is -2x squared. -2 times 2x is -4x. And -2 times -3 is +6. Okay, so that would be your answer on the last one, the function. That would be how you make a representative function. So that's one option, okay? Option number 1. All right, or you could use vertex form. So let's add a page and look at how we can use vertex form. Okay, so let's try our vertex form now. So the other way that we could do this. All right, so remember vertex form is y equals a times x minus h squared plus k. Okay, and we knew that our vertex in the problem from before was -1, 8. And we still need a second point, so we're still going to work with that y-intercept of 0, 6. Okay, so now let's plug what we know into our equation. So we're going to start with our vertex. So we're going to say y equals a times x. Well, it's inside the parentheses. So if it's inside the parentheses, then that means that we're going to switch the sign over. Okay, so if where it was a -1, it's now going to be a +1 because it was a -h in the problem, or in the formula. Squared. And then k stays the same, or the y value stays the same. So it's going to be +8. Okay, now again, you can't leave it with an a in it. You only halfway did your problem if you leave the a. Okay, you don't get full credit for that. Okay, so we have to go use that y-intercept and solve for a. So I'm going to plug 6 in for the y equals, I don't know a, that's what I'm finding, so I need my one thing I don't know so that I can solve. And then I'm going to plug in a 0 for the x plus 1 squared plus 8. Remember, you don't have to do both ways. You can either do the standard form or the factored form to convert it to standard form, or you can do the vertex form. This is for question number 2 when you're writing the representative function. Okay, so let's keep working. So 6 equals a, 0 plus 1 is 1 squared plus 8. 6 times A times 1 squared is 1 plus 8. That's just 6 equals, A times 1 is just A. So then I just need to use my basic equation skills and subtract. So that cancels, and then 6 minus 8 is -2. Okay, so now I have the A. So now we're going to come back to this equation and plug in the A that we found. So that would leave our final answer being y equals -2 times x plus 1 squared plus 8. So whichever one of those makes most sense for your brain, vertex form or factored form, is entirely up to you. Okay, so then from there, you would hop on over to your other documents. So let's do that. And where it says function, I'm going to write what we found. So I could either go, remember, insert, equation up in the top right corner. I could go y equals -2 to get to that. To get to that x one, I'm going to push Shift-6, that little hat top key, squared space, or minus 4x plus 6, or you could have written it in vertex form, and it would have looked like the one we just saw. So it would have been y equals -2 times x plus 1 squared plus 8. Okay, so that's your expectation on A and B of number 2. And on C, let's pop over and see what that one looks like. Part C says the solutions to a quadratic equation with rational coefficients are x plus 3, or x equals 3 and x equals -4. Okay, so for this one, we actually have to set up the equation. They didn't even give us the graph, but they want us to still find. You still have to find domain and range, x-intercepts, y-intercepts, and they gave us the x-intercepts and the zeros. But you still have to find the y-intercept. You still have to find the axis of symmetry. Okay, so here's going to be your best way to do this, as multiple answers are possible. Okay, so don't complicate it on yourself on this one. Okay, let's go ahead and just go y equals, let's write this out in factored form. What if there wasn't an A? What if our A was 1? That's okay. Our A can be 1. Okay, so then I'm going to say, but if you want to give it some random A, you can. So if you wanted to write like 2 in front of that, you could. I'm not going to. I'm going to keep it as simple as I can. Okay, so that's going to be x. Remember, inside the parentheses, it switches signs because it's like it's set equal to 0, that zero product property we learned about. -3 times x, oop, that's a -4, so that's going to be +4. So then, I'm going to multiply that out, and I'm going to put that, so that would be my representative function once I multiply it out, and then I'll show you what we can do with our function. So let's FOIL. So we're gonna shirts and pants, FOIL, double distribute, however you want to look at it. Okay, so we have x squared plus 4x minus 3x minus 12. Okay, and so then I'm going to combine those inner terms. So that's going to be y equals x squared plus x minus 12. Go back to how to multiply binomials that we did on Khan Academy if you need to review that. Okay, so now that's a representative function. One of my things is done. Okay, now let's flip over to Desmos and see how we can make a graph. And now, quick word on Desmos. That's DESMOS.com. Desmos has an app. Desmos can be used on your browser on your phone, or it can be used on your browser on your computer. It's a really good tool. You can also use your Inspire software if you downloaded it. Okay, your Inspire, the software that we sent out that's like your calculators at the school, you can do the same thing with and just screenshot from your calculator. Okay, so let's flip over to Desmos. Okay, so I'm going to push start graphing. I'm going to graph this thing and let it do the hard work for me. So it was y equals x squared plus x minus 12. Look, there it is. Now I can see my y-intercept. I can see my zeros. I can see that it's going to go forever left, forever right. I can see that it's got a minimum. Okay, so you can do your problem just like this. And so then you would go on over to your document, and just like we did on letter A and letter B, you would list your x-intercepts, your domain, your range, your y-intercepts, and you would write the function that we just found right here. Okay, so that's how you do number 2 on your performance assessment. Okay, let's look at number 3. All right, so here's number 3, right here. Just draw your eye there. It says, write a summary describing the relationship between the zeros of the quadratic function and the linear factors of the expression. Okay, so we want you to word this in your own words, but I want you to listen as I explain real fast so that you can somehow just rewrite what I'm talking about, okay? So all this is asking you to explain is that the zeros, the solutions, okay, the x-intercepts, so kind of like what we saw in problem C, these are the same thing, or they can be written as linear factors. So it's kind of like when we applied the zero product property. Whenever we would take the two factors, like if we had something that we had in factored form, we could take each of those and set them equal to 0 to be able to find the solutions. Okay, hopefully you remember doing that. So the relationship between the zeros of the quadratic function and the linear factors of the expression would be if we had x minus p times x minus q, then the zeros, or the solutions to the quadratic function, would be, the zeros would be p and q, and the linear factors are x minus p times x minus q. Okay, so it's like you said, if you set them equal to 0, it has the opposite sign. Okay, so if you were to set those equal to 0, you would be able to get, if you set your linear factors equal to 0, you can find the zeros, or the solutions of your quadratic function. So you can also ask your teachers during tutoring, and we can help to explain and elaborate more. You've been doing this, you just didn't even realize what you were doing. All right, so let's look at these dreaded word problems. Again, remember, this is a mock CPA. These aren't your exact questions, but they're so much like your other questions that you can do this. You can be successful, I promise, okay? You're just gonna have to pay attention to what we do and use your resources, okay? All right, so it says Ruth hits a baseball to right field. The ball is 4 feet above the ground when she hits it. 3 seconds later, it reaches its maximum height of 148 feet. Okay, it says write the function, or write a function representing the problem situation in vertex form and in standard form. And then we're going to sketch the graph. And then, so we'll use Desmos, and you can screenshot it. Totally cool with that. You know, screenshot it from your phone, like your phone, and then attach it to the document. If you're using your phone to graph things, absolutely okay with that. Okay. And then it says identify the vertex, y-intercept, zeros of the function, and justify their meaning in the problem. Okay, so let's look at this. Okay, so we have some special information in here. It says that the ball is 4 feet, says the ball is 4 feet above the ground when she hits it. When she hits it. So you don't start measuring where a ball is at when they're playing baseball. Like if you're measuring from the time, you're gonna start measuring as soon as it hits the batter, as soon as it hits the batter's bat. And then you're gonna start measuring its distance. You're not gonna be starting to measure it like on the batter's swing. The ball's not even to them yet. Okay, so as soon as she hits it, that's when we start our time. So that's when our time is 0. Our x is 0. We just started our time. And then it says she was 4 feet above. So we're talking about height right now. Remember, time is almost always our x value, so that's why it's our x. And then she was 4 feet above the ground, or the ball was when she hit it. So that's our first point. And then it also gave us some more information. It said 3 seconds later, it hit its maximum height of 148. So that means maximum is telling us that's its vertex. And then it gave us a point. The seconds was 3, and it corresponded with a height of 148 feet. Okay, so we have 2 points. So let's flip over and see how we can take those 2 points, kind of like what we just did a minute ago when we were writing a representative function. Let's see how we can take those 2 points, those 2 special points, and write a representative function. Okay? All right, so we're going to use that information. So we had a vertex. Well, let's not use yellow. I can't see yellow. All right, so we had a vertex of 3, because it said maximum, that's how we knew it was our vertex, 3, 148. And we had another point, and hopefully you know it was our initial value. Is right when x is 0, that's our initial value, or what we call our y-intercept of 0, 4. Okay, so when we have our vertex, our mind should immediately go to vertex form, and it gave us vertex form in the problem. So let's look at vertex form. So let's plug this into vertex form. Remember, that's y equals a. Ooh, I don't know what a is yet, so I'm gonna leave it. But I do know the vertex. So open up parentheses, and then I'm gonna say x minus 3, because inside the parentheses it's a negative h, so it means we flip the sign, squared, and then outside the parentheses the sign is the same, plus 148. Okay, so that is step 1. Now I still need to find that a value. So that's where my y-intercept becomes helpful. Okay, so now I'm going to use that y-intercept to go and find my a. So I have a y value of 4 when my x is 0. So we plug it in. Okay. So then now I'm going to solve this. So I have 4 equals a times, well, 0 minus 3 is negative 3 squared plus 148. Okay, now I have 4 equals a times negative 3 squared is just a positive 9 plus 148. Okay, then I'm going to subtract that 148 from both sides. And I'm going to get negative 144 equals 9a, or a times 9. You can leave it just like that if you want, and that cancels. And guys, you can use your calculators on your phone. We're totally okay with that. So we would say divided by 9, divided by 9. So we would say 144 negative divided by 9 gives us negative 16. Our expectation is not that you do all of this without even just a simple calculator, okay? You guys have them in your hands, use them. Okay, so we have 144 divided by 9 is negative 16. So now I have an a value of negative 16. So I'm going to rewrite it here. I'm going to rewrite it back in that original equation. So we have our vertex form. Remember, that was one of the ways we had to write it. And then we're going to have to convert it to standard form. So that's what we'll do next. So we would have y equals negative 16 times x minus 3 squared plus 148. So this was one part of part A of question number 4. So let's flip over to our document that we would be answering all our questions in. So by now we should have probably already had written RC, and we would have had our domain and range and all that good stuff in here, right? And then we would have come down here, and then we would have been ready for number 3. And we would have written our explanation about linear factors are related to ... okay? And then on number 4, I again have an A, B, and C. So I'm gonna say, I'm just gonna label this baseball question. You can do it however you want. I'm gonna push that little tab over so I have a part A. So in the first thing I needed to write in part A was my vertex form. So I just found that. Y equals -16 x, parenthesis, x minus 3, close parenthesis, squared, plus 148. And then the next thing that I had to write was my standard form. So let's flip over and see how we get to standard form. Okay, so let's do this. So we're gonna add a page. We're gonna take that -16 x minus 3 squared plus 148 to the other page. So we have y equals -16 times x minus 3 squared plus 148. Okay, so to convert this into standard form, it takes just a lot of multiplying and combining like terms, okay? So we learned about special products in our Khan Academy progress in these past few weeks. Well, this x minus 3 in the middle is just one of those special products. Okay, so this x minus 3 can actually be rewritten out. So we could actually say y equals -16 times x minus 3 times x minus 3. This is why it was important for us to do all the things in between, okay, so that we know what we're talking about. So special products was, this was a perfect square where we would write it 2 times, and then we can multiply it out. Okay, so then I'm gonna use that shirts and pants or the hippity-hoppity distributive property, and I'm gonna multiply this piece in the middle. Get rid of parentheses first, always. Parentheses, then exponents, PEMDAS still matters. All right, so open up parentheses, and then that's x times x is x squared. X times -3 is -3x. -3 times x is -3x. And -3 times -3 is +9. Keep that plus 148 on the outside. Okay, then I'm going to combine those like terms. I'm going to combine those 2 like terms and leave everything else the same. -16 times x squared minus 6x plus 9 plus 148. Okay, now I'm going to distribute that -16 into my parentheses. So remember, it has to go to everything that inside the parentheses that it touches. Y equals -16x squared plus 96x minus 144 plus 148. Okay, then again, we're going to combine our like terms. Y equals -16x squared plus 96x, and then 144 plus 148 leaves us with a +4, which is good because this should be our y-intercept, and our y-intercept was at 4. Okay, so then our standard form we just found is this right here. So that's the second part of part A. So we would flip on over to our document. And we're going to type that in. So insert equation in the top right corner, y equals -16x squared plus 96x plus 4. All right, and that's part A. So then now for part B, it said to go graph it. So we just need to pick one of these and then go to Desmos and graph it. So again, you can use Desmos on your phone, and you can like email the picture to yourself and then attach it to the document, however works best for you. But Desmos on the computer is also super easy. Okay, so we're gonna go over to Desmos and we're gonna type in that equation. It doesn't matter which one we type in, but I'm gonna say, let's just go with the standard form because this is the one we just did. We just did all that hard work. Negative 16x squared plus 96x plus 4. Okay, so on Desmos, we have little zoom in and zoom out buttons. So you can zoom and then drag, okay? So we just need to see that you have accurately done this, and then you can take a screenshot of this page, or you can, too far. You can take a screenshot of this, of the whole page if you know how to do like a whole page screenshot, or if you know how to do like a snippet of a page, you can do that too. So I'm gonna go take a little snippet of my graph here. It's saved. So now I'm gonna take this, I'm gonna go back to my Word document, and I'm gonna go insert a picture, files, and I just dropped it on my desktop. Insert, and there it is. And so now I can size it down and whatever we need to do for that one. And then that's part B. It's the sketch a graph. You did it. We did it. We're done. And now we're ready for part C. Okay. Part C said to identify the vertex, the y-intercept, the zeros of the function, and justify their meaning. So let's flip back over to Desmos so we can look at exactly what those are. So Desmos will tell us. So we're going to click on our graph, and then we can see our vertex is 3, 148. And then our y-intercept is this point right here. It's that 0, 4. And then our zeros, we have one at negative 0.041. And then we have one at 6.0410. So we have 2 of them. But what I want you to think about in this problem is this is a real world situation. Our x's are only our time. Can we have negative time? Are we time travelers all of a sudden? Did coronavirus help us be time travelers? No, not at all, right? It almost seems like time has slowed down, but it hasn't. So what's actually happening here is this is the motion that we analyzed of this ball when she hit it in right field. It went up, 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 it turned down, and then by the time it hit the ground at 6 seconds and 6.041 seconds. Okay, so then we would justify their meaning. So we're going to write those, we're gonna identify those in our document, and then we're gonna explain their meaning. Okay, so on part C, we have our vertex was the point 3, 148. Well, that was its maximum height. So that means that the baseball reached its maximum height of 148 feet. Yes, you have to write sentences. It's a final. Okay, the baseball reached its maximum height of 148 feet 3 seconds after Ruth hit the ball. Okay, so that's that one. Then we have our y-intercept was 0, 4. So we would say when Ruth first hit the ball, the ball was 4 feet above the ground. This is our initial value. And our zero, in this case, we decided it's only one that's relevant. Okay, if you list both of them, just make sure you explain that only one of them actually counts if we're talking about time. We can't have negative time. Okay, so that was 6.041, 0. we cannot have negative time, so this is the only zero within the bounds of the problem. It represents, it means that at 6.041 seconds, the ball hit the ground. Ta-da! There's question number 4. One more word problem, guys. One more. So let's get ourselves set up for that. So I'm going to push enter. I'm going to go ahead and set this up. Oh, we don't need to do that. I'm going to set this up for question number 5. Go back to our old numbering. Okay, and we are ready. All right, let's flip over and see what question number 5 has for us. All right, so here we are with question number 5. It says, Fernando wants to build a rectangular pen for the sheep he is raising in his agriculture class. Fernando has only has 64 feet of fencing. Okay, he only has 64 feet of fencing. What representative function can be used to model the area? Okay, so he is building a rectangular pen. He only has 64 feet of fencing. Okay, question A says, what representative function can be used to model the area of the rectangular pen as a function of the side length x? So side length is x. And let's stop there. We'll come back to the other ones after that. All right, so here's the thing on this one. It's a rectangular pen, so that means that all the way around that pen, he can only have 64 feet of fencing. So they actually gave us our perimeter, but asked us about our area. So towards the very beginning of the year, we told you guys that there is a special perimeter formula that you need to be able to remember. So we have 2L plus 2W equals, and then this time, or in this problem, it is 64 feet. But if we look at the question number A, or the subpoint number A, it says that our length is x. So let's actually say 2x plus 2w equals 64. Okay, so that means my length is x. So I need to find my width. Okay, so this goes back to those literal equations we did at the very beginning of the year. You have to be able to solve for w. Okay, so let's do that. We're going to solve for w. So first things first, we need to use those skills that we learned of a GCF. 2x plus 2w both have a 2. So I'm going to factor out a 2. So I get x plus w equals 64. And then I'm going to divide by that 2. And I get x plus w equals 32. Okay, and then let's swing over here. So then I get, so let's move this. X plus w equals 32. So then I'm going to subtract x, because I want to get w by itself. So I'm going to subtract x from both sides. So that goes away, and I'm left with w equals 32 minus x. So I now have a width. So I now know my width is 32 minus x. Okay, so once you have done that, that's like your just preliminary steps. That's just us figuring out what are our dimensions, what's our length, what's our width. Okay, so then we can go to question A, where it says what can be used, what equation can be used to model the area, which is A equals length times width of the rectangular pen as a function of the side length x. So we have an area, we're looking at length times width, and we already have our length, which is x, and our width, which is 32 minus x. Okay, so let's take that over to a little more space to write on and see what we can do with that. So we have A equals length times width. We have a length of x, and we have a width of 32 minus x. So let's put those all together. Okay, so we have A equals x times 32 minus x. Ooh. Okay, so now I'm going to distribute that. I'm going to get rid of those parentheses. So I'm going to distribute the x to both pieces. So I have A equals 32x minus x squared. So my representative function would be 32x minus x squared. Okay, 32x minus x squared. It says what representative function can be used to model the area? So that would be our representative function. So we're going to go on over to our document, and I'm going to say sheet problem, and I'm going to say part A, and then I'm going to go insert equation. A equals 32x minus x squared. Boom. B. B just said to sketch a graph of the representative function over the appropriate domain and range and then identify the domain and range. Okay, again, sketching a graph. Sketch it using a resource, whether it's a graphing app or it's a graphing on your computer that you've downloaded, the Inspire or Desmos. So let's hop over to Desmos. So I'm gonna go 32x minus x squared. And then here is my graph. Okay, so here is my graph. So I'm actually gonna take a screenshot of this and I'm gonna put it in my problem, or in my answer document. Just like that. I'm gonna go back, and then we're gonna go insert, new screenshot, insert. There it is. Looky there, you sketched your graph. Nice and easy, right? Use the technology you guys got. Okay, so then it said to identify the domain and range. So we want you to go ahead and identify that domain and range. So what you're gonna need to be able to do that is to look at your vertex. And so let's go back to Desmos and look at that, because you're gonna need that vertex right there, 16,256. 16,256. So you need that point so that you can look at your range, because that's going to give you information about your range, okay? And then your domain. So then you also can see all your other special points you got in here. You got your y-intercept and x-intercepts and your vertex or your maximum. Okay, question or part C said, what dimensions can Fernando use to give the rectangular pin the maximum area? Hopefully when you guys hear the word maximum now, or if it was minimum, but hopefully when you hear the word maximum or minimum, your brain is going to that turning point, that vertex point right here. So our dimensions that we can use would be, remember the side length is our x and our y is the area. So for us to get the maximum area, that 256, our side lengths, both of them would have to be 16. Because if I clicked on any other points around here, if I started clicking around, those, if like one was 9.5, then that means that, or if they're both 9.5, it'd be 210. That's not my maximum. So you can play with it, but you can see if you just know the vocab, your maximum is your vertex. And so then it's gonna be the side length of 16. So our maximum dimensions would actually be if it was a square and it was 16. If it was 16, so it'd be like if it was x squared. So if it was 16 squared, so it was a square, it was perfect square, then we would get that 256. So it's a square if it has its maximum dimension. So then let's go back to our Word document. And in part C, we're gonna say, what dimensions can Fernando give the rectangular pen for the maximum area? So we could say the length and the width would both be 16. How else you could think about that is if you had a square, remember it has to be 64 feet all the way around, okay? So that's how we know that that's 16, it's both 16. So if I had, before I had it as a rectangle, but now I wanna look at that as if it was a square. So pretend that's more like a square. It's kind of hard to draw on these things. Okay, so if I had 16 all the way around, so that would be 4 times 16. Well, 4 times 16, if I was talking about the perimeter, so I had 16 plus 16 plus 16 plus 16, still gives me my perimeter of 64, so I'm still within my bounds, but it maximizes my area, which is what we looked at on that graph. Okay, so this length, the length and the width would be 16. Okay, and then it says justify the reasonableness for your prediction in terms of the problem situation. And so you would just explain what I just talked about how a square would maximize your area because it was the maximum on your graph, as well as because if it was all sides were 16, then you would have the perimeter of 64. But you would also have the maximum area of 16 times 16. And you can play with other numbers or look at your table and figure out other ways that you want to word that. But that's your CPA, guys. I know that might seem like a lot, so hopefully you've broken this video up, but if you made it this far, go you, and guess what? Once you finish it, you're done, okay? So this is what you've got. This is like your final project. It is due May 18th, so take your time. You're gonna have like a week and a half-ish, a little more than that, okay, to get it done. Ask your teachers if you have questions. We are 100% here for you. You got this. We believe in you. We miss you. We love you. Once you finish it, have a great summer.